Guys, so this is starting a new chapter on conics. I prefer to start with parabolas, so I'm starting in 10.3, and then I'll go back and catch ellipses and hyperbola. So parabolas, this is a really different version of parabolas than what we saw back in chapter 3. I'm going to go through some definitions here, and there's you can pull this up in the notes. It's the very first page, 109 of the conics section, and then you can see the stuff hopefully a little bit bigger. So we got kind of four possibilities with parabolas. They can open up or down, and now they can also open left and right. So that's new. So these ones won't be things that are functions. They have kind of three features that are important. There's the vertex still, there's the focus, and then this thing called the directrix. And the vertex to the focus is this distance A right here, and that A is going to come into play in a bunch of places. Pretty much once we have A, we have everything we need to know. And then the vertex to the directrix is also going to be A. So these are equal distance. And to draw the parabola, we're going to go 2A to either side of the focus. What the focus is like if this was a parabolic dish and we had, say, light coming in, it would bounce off of this dish and it would bounce to the focus. So that's why it's called that. So everything that comes in would bounce and come right through here. So this is where they put the receiver. And what the directrix and the focus do is they define this parabola. So the parabola is always equal distance from the focus to the parabola and the parabola to the directrix. So for instance, this distance here is going to be the same as this distance here. Don't need to know that last part for doing them, but that's kind of what these pieces are doing. So we have these four possibilities, and there's what it is it's either going to be x squared or y squared. It's either going to be positive or negative. And so the signs on these actually make pretty good sense. The HK in the formula is still the vertex. The A is this distance that I was talking about up here. X squared and positive opens up, which is kind of what you figure. X squared and with a negative, that's the one's here, opens down. So that also makes sense. That's our reflection that we know from chapter 3. And then y squared positive opens in the positive direction, y squared negative opens in the negative direction. So let's look at some examples, and that's going to make all that probably a bunch clearer. For this first one, we have find the equation of a parabola with a focus at 0, 2, and a vertex at 0, 0. Okay, so I'm going to start with graphing this a little bit. So our vertex is at 0, 0, and our focus is at 0, 2. So that's F, and this one is V. And so what that does, remember back here, the distance from the vertex to the focus is A. So now I know A equals 2. The other thing we know back here is to draw the rest of the parabola is it's going to be 2A from the focus to either side. So since A is 2, 2A would be 4. So my parabola is going to be here and here. And it'll look something, if I drew that a little better, but something like this. If I wanted to draw the directrix in, and on the test you'll want to draw the directrix in, so if it's to this direction, the directrix is always opposite on the other side, so the directrix would be right there. And then just as a reminder, that's y equals negative 2. We'll be asked for that in later questions. So y equals is a horizontal and x equals is our verticals. And so then, since this opens up, I know it's an x squared and it's going to be positive. And so for this one, let me write out the what we're plugging into. So I'm just bringing our x squared positive formula over. So this is going to be x minus h squared equals 4a and then y minus k. And only one side is squared in these. So I know A is 2. They gave me my vertex. That's my HK. It's 0, 0. So it's going to be x minus 0 equals 4 times 2, y minus 0. So x minus 0 is x, and then squared. 4 times 2 is 8. Y minus 0 is just y. And so this would be the equation. So you can see when h and k are 0, when it's centered at the origin, it reduces down to this pretty manageable little equation. So I'll start this one with the graph again. Vertex at 0, 0. So there's V. Focus is at -4, 0. So parabolas always eat their focus, so that means this one's going to be opening this way. From here I can just count the boxes, and I know A equals 4. And I know it opens left. So that means it's going to be a y squared and then negative. Let's see, our directrix would be right here. Again, didn't ask for it, but x equals 4 would be the equation. It will ask for it later. And then since we know a is 4, then to the parabola would be 2 times a, or 8. So from the focus, I'm counting 8 up and then 8 down. And let me just show you on this one all those little a's. So we have a is 4 right here. We have this distance is also 4. And then right here we have our 8, or our 2a. And likewise down here. This is also 8. And then our parabola, I'll do this one a little bit more simply this time. So it's going to be y squared, because I know the h and k are going to drop out. And then equals, it'll be -4 times a, which is 4, x. And so that would be, and it'd be x minus h, but h was 0. So this will be y squared equals -16x. Okay, so number 3 is find the equation of a parabola with a focus at 2, 4. So x is 2 and y is 4. So that's our f. And then a directrix at x equals -4. So that's going to be back here. So there's x equals -4. So we know the vertex is going to be halfway between the directrix and the focus, because that distance is our a. And so counting, I got 1, 2, 3, 4, 5, 6 boxes, so I'd go 3 from either direction, and that puts me right there. So now I know a is 3, that's cool, and I also know the vertex, and that is x is -1, y is 4. And since a is 3, that means it's going to be 6 up to the graph and down to the graph. And then also, since this is v, I can see it's going to open to the right. So this is going to be a y squared positive. So counting up 6, I'm here and there, I believe. So that would be the graph. And then to get the equation, and I'll write it out here since I'm substituting stuff in. So there's the equation from the first page if you look at the one that opens to the right. So y squared and positive. And then I know a, I know h, and I know k. So, h. So I can just substitute those in, and then that'll be my equation. So it's going to be y minus k, so y minus 4. And then 4 times 3, x minus -1. And watch the double negatives on these. So y minus 4 squared equals 12. X minus -1 is x plus 1. And so one more, find the equation. And this one we're given the vertex and the focus. So we know hk. And once I get these graphed, I can get a in the orientation. So for my vertex, it's at 4, 1. So that's right there. And then the focus is at 4, 4. So that's right there. So this is going to be an x squared positive because it's going to open up. And we know a is 3. And we have our vertex up there. So that's pretty much everything we need. With a being 3, I'm going to count 6 either side of the focus. So 4 and 6. And that's going to define the rest of my parabola. If I needed the directrix, just to complete the graph, it'd be right here. And that's at x equals -2. And then we'll do, this one's going to be x minus h quantity squared equals 4a y minus k. If you go back and check that picture. And then plugging in, I'm going to have x minus 4 and this is going to be 4 times a was 3 and then y minus 1. Oops, squared. So x minus 4 squared equals 12 y minus 1. Okay, so for question 5, it changes a little bit. Now they're giving us the equation. Soon they'll give us something close to the equation, and then they're asking us to find all the stuff. So looking at this, right off the bat, I can get the vertex. So the vertex, careful, it's not, so there's 2 places to be careful. When you plug the values in, what ends up happening is they come out backwards because the minus is in the formula. So like when I plug in a negative 1, it shows as a positive 1. When I plug in a positive 4, it shows as a negative 4. So we're seeing the opposites. The other thing that could be tricky is people want to write down, okay, so negative 1, 2, except this is your y and this is your x. So it's going to be 2 and then negative 1. So opposite sign, and they just, in this formula, they appear in the reverse, alphabetical, so you just have to be careful to flip them. And that's really, really common error, is to write down the 1 or negative 1, 2 instead of 2, negative 1. So let's get that graphed. So when x is 2, y is negative 1. I'll be right there. The other thing we know up here is it's a y squared negative, which means it's opening to the left. And I know that this 8 right here is 4a. I'm going to drop the negative because that's the opening to the left piece. I want to figure out what a is. And so there, a is 2. Once I know a, that gives me a lot of information, because now I can get, if this is my vertex, then the focus, and I know it opens left, and a is 2, then the focus is going to be right there, 2 to the left, and the directrix is going to be 2 behind it. If I want to finish drawing my graph, from here I'd count 4, because it's twice the a value, which was 2. So 4 here, and 3, 4 there. And that gives us the rest of the parabola. So in terms of the rest of the stuff, we got the vertex. The focus I can now read right off the graph. So f is x is 0 and y is negative 1. Axis of symmetry, so that's back here. And remember, vertical lines are x equals. So x equals 4 would be the equation. I suspect the computer would want the equation. Oh, sorry, that was actually the directrix. The axis of symmetry is this other line. That's this one. And so that's like if you folded the parabola over. And so the directrix was the x. That's here. The axis is y equals negative 1. And then we got our graph over there, so I think we got all the pieces. So for number 6, you'll notice it's not really in the form that we're used to seeing it. And so all those times, if you had me for Math 95, where I'm like, you're going to need completing the square for other stuff, this was the other stuff. So what I'm going to do is I'm going to isolate the y terms, because that's where I want to complete the square. So I'm going to go minus 8x minus 28 on both sides. So I'm getting these y terms by themselves. So this will be y squared minus 4y. I'm going to leave some space right there. And then this will be negative 8x minus 28. And then here's where I have to complete the square. So I'm going to go half of 4 is 2, and then squared it, and then that makes it 4. So we're going to add 4 onto both sides. And what that lets me do is get this factored into that y minus k form. So this will be y minus 2 squared. And then on this side I end up negative 8x minus 24. And there should be some nice little bit of factoring you can do here. And so in this case it's y minus 2 quantity squared. If I take out a negative 8, now I have x, careful with that sign, plus 3. And I always like to distribute it back in my head and make sure I didn't mess anything up. So there's my negative 8x, and then that'd be a negative 24. So now that I have it in the right form, now I can see all the rest of it. So for starters, I have, well, 4a is 8, so a is going to be 2 again. And this is a y squared negative, so we're expecting it to open to the left. We know the vertex is x is negative 3 and y is 2. We know the focus once we get it graphed. The rest of this will all kind of come into play. So for a vertex, just have parentheses, negative 3, positive 2, so we're right here. That we know it's opening left, so that means this is going to be the directrix back here. The focus is going to be 2 in front of it. From the focus, I can go up 4 and down 4. That defines the rest of the graph. And then this will be my axis of symmetry. So let's see, the focus is going to be at negative 5, 2. Let's see, Directrix is the green ones, that's at x equals negative 1, and then the axis of symmetry is going to be the purpley one, which is at y equals 2. Okay, so for number 7, same basic question, finding all the same things. This time we have an x squared term, so that means I'm going to want to isolate x squared, get the y and the constant over. And so I'm going to complete the square in x. So we're going to go minus 4y minus 1, minus 4y minus 1. So this will be x squared plus 6x. I'll leave myself some room. And then minus 4y minus 1. And then here's where we do half of 6 would be 3, and then square it, and we get 9. So 9 is what we need to add on to both sides. Factoring here, I get x plus 3 squared. Over on this side, I'm going to get 4y plus 8. I'm going to factor that 4 out of there. I'll make negative 4, and then y, that'll be a minus 2, because it's going to flip the sign. So negative and negative get me back to positive 8. And that's the spot, when this is negative, to be really careful with your factoring. So since 4a equals 4, a equals 1. Again, I ignore the sign when I do that. It's x squared negative, so that's where I care. That tells me it's going to open down. And my vertex is going to be at negative 3 and positive 2. And then from there I'll get the graph and everything else. So x is negative 3 and y is positive 2. So that's going to be right here. A is 1, so my focus, and it's opening down, so my focus is going to be right below it. And then the directrix will be 1 box right above it. So this is y equals 3 this time. And we also know that from the focus to the parabola, that's 2a, so that's going to be 2. So I just count 2 boxes either direction. I end up with this little parabola right here. So there's my 1, 2, 2. And then just writing down everything I found. Our focus is at negative 3, 1. Directrix is at y equals 3. And then the axis of symmetry would be right here. And that is at x equals -3. And that's parabolas.